Hi, and thanks for taking time out of your day to come learn about AMD HPC Solutions. My name is Michael Detwiler. I am part of the AMD Server Business Unit. Let's jump right in. We're currently shipping our second generation AMD EPYC processors. Simply put, they are the highest performing x86 server processors on the market. We deliver up to 64 high performance cores for incredible throughput. This gives us leadership performance, in some cases more than double the competition in certain applications. But it's also got a well-balanced design from a memory and IO bandwidth perspective, and all this is tied together with innovative new security features. Digging in a little deeper into some of the speeds and feeds, I mentioned 64 cores. This is really giving a tremendous amount of throughput when it comes to HPC applications. It's an industry-leading core count, but we also have other options down, starting at 64 down to 8. So whether you're looking at complete raw throughput or looking at some sort of a sweet spot in price performance or performance per core, perhaps you need to optimize around um, your software license fees. We have a solution for you. We also have tremendous IO bandwidth. So we have 128 lanes of PCIe Generation 4 built into each processor to deliver double the IO throughput that we had from our first generation EPYC processors. But all this is balanced by our memory bandwidth and our memory capacity. So our memory bandwidth is one thing that has really struck customers as providing great performance for some of their memory bound applications, whether you're thinking computational fluid dynamics or similar. We're really able to balance the compute and the IO with the memory to feed those cores. And then if you're running some sort of in-memory analytics, we're able to provide incredible memory density with up to 4 terabytes per socket. If you look at some of the customers that have deployed AMD today, you'll see some names that you recognize. You might recognize some of them as very large research institutions, but it's not all about just extremely large customers. We have a lot of universities or smaller research labs that might buy 20, 50, 100 nodes. We really have a solution that fits a lot of their needs. And it's because of our innovative architecture, our performance, and just the application performance we're bringing to the workloads that they're running. We're very excited to be part of the Exascale era. So the US has announced 3 Exascale systems for the future, and AMD was chosen to be in 2 of those, both from a CPU and a GPU standpoint. So the first one announced was from Oak Ridge National Labs, codenamed Frontier. This is one that will be, shipments are planned for next year, 2021. And then recently was announced El Capitan from Lawrence Livermore. This is one that will be shipping planned shipments in 2022. And as you think about, why customers are deploying now and have decided to deploy for the future, it really comes down to innovation. So you've got the high performance cores, but those are built on an innovative new CPU architecture that we'll talk about in a second. And then we have new concepts for heterogeneous computing to deliver optimized compute engines, and we very much embrace an open ecosystem from a software perspective. So if you're looking at your software stacks and your frameworks, we want an ecosystem that allows for innovation as opposed to locking customers into some sort of a proprietary solution. As you look at our roadmap, when we first launched ourselves back into the data center market from a CPU perspective, we put forth a plan and multi-generational roadmap that was built on the back of a new high-performance core that we called Zen. And we continue to, improve and modify that core over time. And we have a multi-generational roadmap that we've been executing to, and that's really been one of the keys to our success. It's one thing to bring out a product that is great from a performance standpoint, but you have to, in order for customers to really invest in you now and in the future, you have to be able to show that you can execute on your roadmap and continue to execute on your roadmap across multiple generations. So we're now in our second generation AMD EPYC, and we're going to be continuing to innovate and bring out products in the future. You might have heard the codename Milan. That will be our third generation. And if you'd like to, have further, deeper discussions under NDA, we can give you more details and timing on our multi-generational roadmap. On the GPU side, we have a similar strategy. We know that we need to gain customers' confidence, so we have a multi-generational roadmap that started with MI25, moved to MI50. Both of these products are shipping, and then we have new products that will be brought to market. Right now, they're just codenamed MI Next. The point here is that we've made a long-term commitment to the data center, both on the CPU side and on the GPU side. And if you think about the wins that we had from an Exascale standpoint, those customers are choosing AMD now and in the future because of our ability to execute on our current products and the innovations that we're showing for the future. Now, when we look at, from a CPU standpoint, when we look at the design, I mentioned an innovative new design. So it's something that we call the Infinity architecture. And it really comes down to, we have a multi-die, a multi-chip module that is tied together by something we call the Infinity fabric. So this is something that is a low latency, high bandwidth fabric. It really is one of the keys to how we are able to generate the performance, the scalability, the efficiency we get from our processors. And all of this is hardened by our advanced security features that we call AMD Infinity Guard. I've mentioned performance. Let's look a little closer at performance. So whether you're talking about specific applications, structural analysis applications from Radios, or CFD from ANSYS, or crash simulation from LS-DYNA, or something more generic, something from the spec CPU suite, we really are delivering fantastic performance. So what you see here are some comparisons of our kind of the top of the line 64 core product versus a top of the line competitive product from Intel, and you're seeing anywhere from 70% up to almost, or up to 100% better performance. And that's really from a combination of not just having a lot of cores, having fantastic memory bandwidth, and just the overall balance of the architecture. About 6 weeks ago, we launched 3 new models into our lineup. So the current generation, or the 7002 series processors, we launched 3 new products that were designed specifically around optimizing performance per core. So these are the 7F32, 7F52, and 7F72. Those are 8, 16, and 24 core products. And the way we optimized around performance per core was really around 2 different vectors. Frequency is always very important, and certainly these were optimized around frequency, but they're also optimized around cache and cache per core. One of the benefits of our multi-chip module or multi-die approach from an architectural standpoint is it allows for great flexibility in how we build parts and how we build products. And so we were able to optimize and maximize the cache per core by the way we build the products. So these 3 SKUs have been optimized around both frequency and cache and cache per core. And so really what you see here is the balanced approach. When you look at the same applications we just looked at in the previous slide, and you see how we compete from similarly positioned products from our competition around performance per core, we have a tremendous performance advantage. And this comes from a combination of having strong cores from an IPC perspective, high frequency, high cache per core, fantastic memory bandwidth. All this comes together, and we have industry leading performance on common HPC applications. Another thing that differentiates us is the way we bring the products to market from a model number standpoint. So, we believe that we want to make it as simple as possible for people to hone in on what the right SKUs they need to choose from an AMD perspective. And so we really differentiate our models by 4 key points: number of cores, the frequency of those cores, the power of the socket, and of course price. You're going to pay more for a 64 core than you do for an 8 core. That's just the way it works. But those are really the four things that we want to differentiate around. The other things that I like to refer to as the uncore, so things like memory support speeds, memory capacity, number of lanes of PCIe, whether or not your turbo is enabled or your multi-threading is enabled, the bandwidth of your fabric between the processors or having security features, all of those come as standard, whether you're buying the least expensive 8 core or the most expensive 64 core. And so the way we like to, have conversations with customers is, what's the right level of compute you're looking for? And are there any power or, budget considerations that we need to take into account? And so that's how we kind of start to hone in on what is the right SKU for you? What are you trying to accomplish? Are you just trying to, brute force as much throughput as you need? Are you trying to optimize around, a performance per core, or get the most out of your software licensing investment? What are you really trying to accomplish from a compute standpoint? And then let's talk about, are there, power or budget restrictions that are going to lead us kind of into a certain SKU there. The other thing I want to point out on this slide is you see in blue there, it says single socket, and you see some model numbers with a P. I just want to quickly explain kind of the difference. So all the SKUs you see there in white are enabled and work just fine in single socket boards as well as dual socket boards. The model numbers in blue with the P are only going to work in single socket configurations. And the way we did that was the P SKUs have the Infinity Fabric fused off, so you can't buy 2 of those and plug it into a dual socket board. And the reason why we did that was because we gave it a more aggressive price. So if you look at something for example in the second column, the 7302P, it has the exact same speeds and feeds as the 7302. It's the same cores, same frequencies, same power, same memory speeds. All of that is the same. The difference of the P SKU is the Infinity Fabric has been fused off, so you can't buy 2 of those and put them into a dual socket board. And it also has a more aggressive price. And the reason we did that is because we believe we have a definitive differentiation in single socket SKUs, and we wanted to kind of double down on that differentiation and really provide a unique value proposition for customers that wanted the efficiency of single socket, but still getting traditional dual socket performance and feature set. The ecosystem has also been another strength. So we have been embraced by the world's leading OEM and ODMs from a platform design standpoint. We work with a large number of regional OEMs or system integrators that specialize in HPC. And so from a platform perspective, it's been a really fantastic journey for the last 6 or 7 years as we've been in product development and bringing products to market. The other area that we really focus a lot on is around the other parts of the ecosystem, both hardware and software. So we have great relationships with your memory vendors, your drive vendors, your network or your NIC vendors, accelerator vendors. So obviously, I've talked about AMD Radeon, but you might be surprised to know that we actually have a close relationship with NVIDIA. And so we work just fine with NVIDIA GPUs as well. As well as Xilinx. And so, we make a point to have tight relationships because we do really believe that through those type relationships in an open ecosystem, that's where real innovation takes place. We also partner with all the leading OS vendors that you would think of, as well as a lot of the key ISVs around optimizing around our architecture, their software around our architecture. Compiler and libraries. This is a common question when we talk to HPC customers. So the optimized compiler for AMD processors is something we call the AOCC. We have put a lot of resources, a lot of investment behind our software strategy in HPC. And so our optimized compiler is called AOCC. We have open source libraries. We have performance and power profiling tools. All of these can be found for free on developer.amd.com. So they're free to use. Again, we put a tremendous amount of resources, and if you're looking for maximizing performance on our processors, that is where you would want to go. We also work and are compatible with LLVM as well as GCC, some commonly used compilers as well. Kind of in conclusion here, we have really come back with a force in the HPC space. We had some really great wins and some traction with our first generation EPYC. Moving to second generation, the traction has continued to go up. We continue to gain market share. It really comes down to, not just the product. Product is great, but our customers have seen our ability to execute over the last 3 or 4 years that we've been bringing products to market. We've been consistent with our roadmap, so it hasn't really changed much from from a product standpoint, from a feature set, from a timing standpoint. So a lot of roadmap consistency, our ability to execute. But at the end of the day, it's about performance in HPC, and we have the highest performing x86 processor on the market. We have fantastic application performance across a number of workloads that you're running today. We have great performance on more general purpose workloads such as the spec suite. We're going to be powering the fastest Exascale system, so that's proof that people that are really digging deep into our technology and our ability to execute believe in what we're bringing out in the future. And most importantly, we have really strong ecosystem support. So this can't be done on our own. We realize that, and so we partner very closely with other parts of the ecosystem. So in conclusion, if you'd like more information, we have an HPC dedicated website on AMD.com. You can try to scribble down that address, or very easily just Google EPYC for HPC, and it should be the very first return that you get from a search perspective. I really appreciate your time, and hopefully we continue the conversation later. Thanks.